Hello guys, I am Vivek Sattu and today we are going to learn about Newton's laws of motion. So let me tell you what Newton is first. Newton is actually the name of the person who has given us these laws. So his full name was Isaac Newton and was called Sir Isaac Newton. He was born on January 4, 1643 in England. Was an established physicist and mathematician and was credited as one of the great minds of the 17th century scientific revolution. And with discoveries in optics, motion, and mathematics, Newton developed the principles of modern physics. So now the another question may arise in the minds of students that how did he come up with the laws of motion? So well, these laws are basically laws of nature, and the fact was that Newton was the first one who noticed the phenomena that was happening around us, and just wrote it down in the form of mathematical equation. Nothing unusual. So coming on, this is a Newton's first law of motion. So before coming on to Newton's first law of motion, I must tell you what is force, what is acceleration, and what is inertia. Because first law is also called as law of inertia. So you must be familiar with these terms to understand these laws. So what is force? Force is any interaction between two bodies, and when unopposed, will change the motion of one body. So force is like when you are when you are pushing or pulling some object, you are exerting a force on it. And that means if you push an object and you exert a force away from yourself, and you pull, you exert a force toward yourself. So that's the unit of force is Newton, and you are familiar with force, so no need to teach you about that. So coming on to acceleration. See, acceleration is nothing but the change in the velocity with respect to time. So what acceleration is, and velocity is actually the speed and direction. So changing your speed, changing the will or changing your direction is the acceleration. If you are moving in a sitting in a car and moving going forward in the road, and your the velocity of the car is constant at 20 miles per hour, and you are not changing direction, that means there is no acceleration. But when you hit the accelerator pedal, you are changing your velocity speed now from 20 to 30 to 40. That means there is a change in velocity, that means there is acceleration. And when you stop the vehicle, there is also change in velocity, that means there is acceleration. And when you use steering wheel to turn to the left or right, that means you are changing your direction, and that is also the acceleration. And as a unit of acceleration is meter per second square. So now what is inertia? You must be familiar with inertia to understand the Newton's first law of motion. So let me tell you what is inertia. See, what is inertia? Suppose there is a big sofa and you are pushing it, but it is simply not moving because it has a tendency to not move. Things like to do what they are doing. So sofa is not moving. Let me give another example. See, there is small stone in your hand and you are pushing it and it is moving, but after some time it is eventually stop. So question is, I told you that the thing want to do what they are doing, so how did it stop? So there are some obstacles in the way of this stone that is resisting or preventing the further motion of this stone. So first one is air pressure. Yes, our atmosphere is filled with air. So when the ball goes through the air around the ball is exerting a force and thus preventing the further motion of the stone. Second one is friction. Yes, if the ball is or stone is moving on the ground, there is a friction between ground and the ball where some energy loses and it eventually stops. And third one is obstacles. Obstacles can be anything, a tree, a car, a wall, a person, different stones, anything can be obstacles. See, the obstacle here is a tree, and when you throw the ball, push the ball, it obstacles, it stops. So See, there is another example. If I throw this ball from here, will it make it up to this point? No, because there is obstacle, a turf. See, it will eventually stop here. See, if I throw this ball from here, it will go from there because there is no obstacle, but there is friction and there is air pressure. So it will eventually stop after some time. So if you throw a ball in outer space where there is no gravity, there is no air, no friction, no obstacles, if you throw a ball in the throw a stone or ball in the outer space, it will continue to move forever because there is no force on it. Acting upon it, no force, so it will continue to move. So we can say, see, if you throw a ball in outer space, it will continue to move like this. So we can say things want to stay in the position they are. As an example, a book is placed on the table and remains on the table as time passes, unless you move the table or throw the book. So that means things want to stay in the position they are unless acted upon by an external force. So things want to keep doing what they are actually doing. So this phenomena is called as inertia. So this explains our Newton's first law of motion. An object at rest stays at rest and our object in motion stays in motion unless acted upon by an unbalanced force. So a book will remain on the table forever if you don't move the table or the book. Yes, and ball you throw will continue to move unless friction or air pressure or obstacles and gravitational force is acted upon. So that means our Newton's law, first law of motion is completed. Now coming back to Newton's second law. So acceleration is produced when a force acts on a mass. When a force acts on a mass, it produces, it will move the body. So it will move the body means its velocity has been changed. The change in velocity is acceleration. And what he's saying, acceleration produces when a force acts on mass. The greater the mass, the greater the amount of force needed. You simply know this. You have also observed this in your daily life. Heavier objects require more force to move the same distance as lighter objects. So when you pick up a small bottle, you need small force. But when you try to pick up the lift the bucket, you need large force. So in mathematical expression, we can say his force is m into a, where F is force Newton, mass is kg, and acceleration. So let me show you. This is a small person with the small mass and large person with small mass. So when force is constant, there is, according to this, when force is constant, mass is directly proportional to inversely proportional to acceleration. See, so it moved this distance, and same force is applied to this guy. It moved this distance because its mass is large. So we can say that when force is constant, acceleration is inversely proportional to mass. So let me give you another example. When mass is constant, see this guy and this guy same mass is constant. Now force is changed, so it will move this distance. So when you say when mass is constant, force is directly proportional to, yes, acceleration. If you throw the same bottle, if you push the bottle, it will move for some distance, and if you push more harder the same bottle, it will move more further. So more the force, more the acceleration. So that proves our Newton's second law of motion, F is equal to ma. Now coming back to Newton's third law of motion, for every action there is equal and opposite reaction. Action reaction pair is everywhere. You can see the air rushing out from the balloon is action, and it is giving thrust, a reaction, that is balloon goes up. So see a swimmer. A swimmer pushes the water in the backward direction, and the water exerts a force on the swimmer that moves it, takes it to the forward direction. So this was it. I hope you understand, and if you have any queries, you can, I have given the description the link of my email, you can mail me. Thank you.